Hey guys, this is the largest student loan I've ever seen. I kind of want to know what the monthly payments are going to be. Let's do the math and find out. This is the formula to find the monthly payments. M is equal to the monthly payment. P is the principal, which is the initial or the current amount of your loan. These R's are going to be equal to the monthly interest rate, and N is equal to the number of months. So for the monthly payment, that's what we're trying to solve. Let's put a little question mark. And then for the principal, that's going to be the total loan amount. So we can plug in the total loan. $590,506.36. And then for the rate, it says there are 31 loans between 3.4 and 9.08%. Let's choose something in the middle like 6%. And then we want to divide that by 12 to get the monthly rate. 6% divided by 12 is equal to 0.5%. And then we want to express this as a decimal. It'll be 0.005. And then to get the number of months, it says up here it's a standard repayment plan. So it looks like a standard plan repayment term for 100,000 or more is 25 years or 300 months. So in the place of N, let's plug in 300 for the months. And now we can bring this down here and plug everything in. In the place of the principal, we can plug in this number. In the place of the R, let's plug in this number. And then for 1 plus R, it'll be 1.005. And then for this N exponent, it's going to be 300. This will become 1.005. And this will also become 300. Now we can plug the top and the bottom into a calculator and we end up with this. And then this divided by this is equal to this. The monthly payment will be $3,804.64. Let's bring it up here and give it a label. So for 25 years, they're going to make monthly payments of $3,800. That's 300 monthly payments. If we multiply this by 300, that gives us a total amount paid on the loan of $1.1 million. That's almost double the value of the loan today. I wonder how much of this went to interest. If we end up taking the total and subtracting the current loan value, that's going to give us the value of interest. In this payment plan, it's going to end up being about $551,000 in interest. That's almost the size of the loan. Let's clean things up a little bit, smush it all together, and put a box around it. So hopefully they got a really good job, because $3,800 a month for 25 years, that's a lot of money. I wonder if we pay a little bit more per month, if this will shrink by quite a bit. Let's find out. Let's bring back this equation and let's get the N all by itself. Let's multiply both sides of this equation by this denominator. On the left-hand side, we're going to have M times this. On the right-hand side, these are going to cancel each other out, leaving us with P times R times 1 plus R to the N. And then from here, this M can distribute to each of these terms. M times this is M times this. And then we can subtract from that M times 1, which is equal to M. And then we can copy down the right-hand side. And then next, let's get everything with an N on the left-hand side and everything without an N on the right-hand side. To move this over here, let's subtract it from both sides. And to move the M over here, let's add M to both sides. On the left-hand side, this negative M and this positive M are going to cancel each other out. So we're going to be left with M times this minus PR times this. We can rewrite that as M minus PR, whole thing times this. And then on the right-hand side, these are going to cancel each other out, leaving us with M. Next, we can divide both sides by the M minus PR. On the left-hand side, these are going to cancel each other out. And on the right-hand side, we have M divided by M minus PR. Now we have our variable in an exponent. The best way to get it out of the exponent is to take the logarithm of both sides. Anytime you take a logarithm of something, the exponent of that something can be brought to the front of the logarithm. Here's the notes right here. And now to get the N all by itself, we can divide both sides by the natural log of 1 plus R. On the left-hand side, these are going to cancel each other out. And on the right-hand side, we have all of this. Now we have the value for N, which is the number of months. Let's double check to make sure we did all the work right. In the place of the M's, I plugged in this monthly payment. In the place of the principal, I plugged in the total loan. And in the place of these R's, I plugged in the monthly rate of 0.005. After plugging all this into a calculator, you get 300. So we did do all of this correctly. Let's make a table and compare some values. So for the monthly payment of 3,804, it ended up being 300 months. And then to get the total interest paid, you end up multiplying the 300 times the monthly payment minus the principal. So in this case, it ended up being around $551,000. Now I'm a little bit curious, what happens if we double the monthly payment? Let's plug in $7,609.28. And after we plug all of this into a calculator, we end up with about 98.46 months. We can update the table here. How much are we going to pay in interest for this one? So after we do 98.46 times this minus this, we get $158,703. So by doubling your monthly payment, you end up cutting the length of the loan to less than a third of what it was before. And the interest paid ends up being about a quarter of what it was before. That's pretty crazy. Of course, this is a humongous monthly payment, so it makes a lot of sense. It'd make a big difference. So what if the person can't afford double, but they can pay like $500 more? So let's put $500 more, $4,300. What would that end up giving us? That ends up being about 232 months. So let's update that here. So then if we multiply the number of months times this monthly payment and subtract the loan amount, we're going to have an interest of about $409,000. So by doing just another $500 per month, you end up saving $142,000 in interest. And you pay off the loan in, what is that, about 75% of the time? Yeah, it's about 77% of the time. So even just the $500 would make a big difference. I'm kind of curious what happens if we do just $100. Let's plug that in here and we end up with about 283 months. Let's put 283 here. So then after we do this number of months times this monthly payment minus the total loan balance, the interest ends up being $514,000. So by paying just an extra $100 a month, you shorten the loan length by about a year and a half, and you end up paying about $36,000 less. Whoever has this loan, I hope they make as large as payments as possible. It'll pay off in the long run. The original goal of this video was just to find this monthly payment, but I find exponential growth fascinating, so I wanted to play around with it a little bit. And if you want to do some more exploring with exponential functions, I highly recommend this course on Brilliant. They've got this whole course on exponential functions and has some awesome interactive elements. You can tell they put a lot of thought into the lessons. They're carefully crafted by experts. World-class teachers from MIT, Harvard, and Stanford. It's so much better than watching a video. You can actually interact with the lessons and you get a much stronger connection with the material. I'm currently going through this course on quadratics. I already know the material, but I'm fascinated with the way they explain it. I personally love to use these squares when factoring. I've never seen a tool that actually moves the squares like this so you can see the product that you're trying to factor. I wish everybody could see this when they're trying to learn factoring, especially the scenario when a does not equal 1. It makes it really easy to see how one constant is multiplied by a different value than the other constant. I think a lot of students could benefit from a tool like this when they're trying to learn how to factor quadratics. If you'd like to try Brilliant for free for a full 30 days, visit brilliant.org/andymath, scan the QR code on the screen, or click on the link in the description. If you use this link, Brilliant is offering 20% off an annual premium plan. That'll give you unlimited daily access to everything Brilliant has to offer. How exciting.